Hello. So this will be the second virtual lab, which is the lab called 5 White Powders. And so what we're going to be doing today is studying how these 5 compounds react with water to check their solubility. We'll then check the pH, so whether or not those solutions are acidic or basic when added to water. We're then going to examine what happens when we react those solutions with nitric acid, followed by sodium sulfate, and then finally silver nitrate. So we're going to fill out this table with all of these observations about how these compounds react under these specific conditions. And then using those observations, we're going to examine a sample of some unknown mixture of 2 of those compounds. So we'll take our unknown mixture and then we'll take it along the path of those reactions, and then based on the observations of how those mixtures react, you should be able to determine which of these 2 unknowns are in our mixture. So I have some test tubes set up, and I've already added the 5 unknown solids. They're right here, and I have them in the order that they are in the table. So this is barium carbonate, barium chloride, barium sulfate, sodium carbonate, and then sodium chloride. So let's get started. The first thing I'm going to do is add water. And this will determine solubility. Okay, so barium carbonate is not dissolving, so I am going to pretty definitively call that guy insoluble. Barium chloride, more or less gone clear, so I think that guy's pretty soluble. Barium sulfate, very insoluble. So this guy looks like it's trying to dissolve, so I'm going to add a little bit more water just in case I just added too much solid. Same thing for the next, because as you can see for these 2 guys that are definitely insoluble, the solution itself is pretty cloudy. Those guys have pretty clear solutions, which makes me think that they were just saturated, so I had too much solid and not enough water. And yeah, so as I added more liquid, more and more of those solid parts have dissolved. So let me just really max that guy out. Yeah, so as I add more, it's dissolving. So I'm going to call those soluble. So I'm going to then plug in that data. So barium chloride, not barium chloride, barium carbonate, we found to be insoluble. Then barium chloride, soluble. Barium sulfate was insoluble. And then these last 2 were soluble. Okay, so yeah, definitely the longer it sits, the more it dissolves. Those guys are definitely soluble. So the next part is we're going to check the pH, which is the acidity of this solution. So in order to do that, we're going to add something called a universal indicator. So what an indicator is, it's some compound that will be one color when it's basic and then a different color when it's acidic. And the way this works is that when a solution is basic, the compound will be deprotonated which will give it off one color, and then when it's acidic, it will be protonated, which will give it a different color. And we'll definitely talk more about this stuff once you guys get to acid and base chemistry. It's some pretty fun stuff. Okay, so let's just drop in a few drops here. Okay, so now we're going to use this chart. Recording it. It's very difficult because now I don't have all my hands. Okay, so it's this little chart that relates the color to the pH. So let's start with barium chloride, barium carbonate, excuse me, sorry. So it seems to be kind of, where's the camera? Kind of like a turquoisey blue-green color. So comparing it in here, I would say the closest would be 8. So I would give that guy a pH of 8, which would make it basic. Now this is a pretty sharp green color. So the sharp green kind of looks closer to that 7, because as it gets more basic, there's more of like a bluish tint to it, and I think I would call that about 7, which would be considered neutral. So that's the barium chloride. Now barium sulfate, it's kind of hard to tell because there's a lot of white in there that's changing the color, but that looks pretty green to me as well. So I'm going to call that one 7 in neutral. Barium carbonate here is pretty, not barium carbonate, sodium carbonate. Sorry again. So sodium carbonate looks to be about 9.5, maybe even 10 with how purple it is. So that's very basic. And I'm going to call that about a 10. And then finally, sodium chloride. Yeah, that is green and neutral, which you would expect because, I mean, that's just salt water. So let's come back over to our table. Barium carbonate we called basic, and that had a pH of 8. Barium chloride, I believe we said was neutral. So pH equals 7, and then that was the same for barium sulfate. Sodium carbonate, on the other hand, was very, very basic. It had that very pretty purple color. So pH equals 10. And then lastly, sodium chloride was another neutral. So pH equals 7. And again, those are more or less estimations based on site. So the next part of this experiment has us add 3 molar nitric acid. And so we're going to add it until the solution becomes acidic. So when it's acidic, we're going to be looking for that red color. So all of these solutions will eventually turn red because the universal indicator is in there. And this is a very strong acid, so eventually they'll all become acidic. But what we're actually looking for is some fizzing. So if it fizzes, that means that there is a carbonate ion present. So there are two compounds, the barium carbonate here and then the sodium carbonate here, that have carbonate in the compound. But remember that one of those, barium carbonate, was insoluble. So in theory, this guy shouldn't fizz at all because the carbonate is still in its molecular form. It's not an ion. So it, in theory, shouldn't fizz, whereas the sodium carbonate, since it was soluble and has then broken up into its barium and its sodium and carbonate ions, it should fizz when this nitric acid is added. What's happening with that fizz is we're generating carbon dioxide, and so it will bubble as it leaves. So let's start adding. Well, look at that. We are seeing some bubbling with this first guy. Now, everything is kind of semi-soluble, so even though there was a precipitate there, that means that there were still a few carbonate ions in solution. So red plus fizzing. For the barium sulfate, I'm just gonna add a little bit more just to make sure I get it fully acidic. There we go. Okay, so moving on to the barium chloride. It turned red right away, no fizzing. Now the barium sulfate, it's that green guy right there, turning red without any fizzing. Now I'm actually going to skip over the sodium carbonate just because it's the cool one, and let's just do the sodium chloride real quick. Red, no fizzing. And now let's take a look at sodium carbonate. See, as you can see, it's fizzing way more than the barium carbonate. And that's because all of its ions are in solution, whereas barium carbonate just had some of them. So we're gonna come on over and record those results. So with the reaction with nitric acid, it was red, some fizz. Barium chloride turned red, had no fizzing. Barium sulfate, red. Sodium carbonate, red with lots of fizzing. I can actually still hear it going. And then sodium chloride just turned red. Yeah, it's still going a little bit over there, if you can see it. Okay, so for this next part, we're actually going to divide the solutions into two. So I'm going to pour half of each into another solution. So I'm just gonna rearrange them going down. Okay, so before we get started, I'm going to pour half of the solutions into the test tube next to them. So this is the barium carbonate. Here is barium chloride. Barium sulfate. sodium carbonate. When I poured it, it mixed it up a little bit more and it started fizzing. So a lot of carbonate ion there. And then lastly, sodium chloride. Okay, so the test tubes on the left, I'm going to do the reaction with sodium sulfate, and then the test tubes on the right, I'm going to react with the silver nitrate. So, starting with the 0.1 molar sodium sulfate, I'm going to add, and what this will do is if any barium ion is present, it will form a precipitate, so a solid. So we have 3 compounds that have barium in it: barium carbonate, barium chloride, and barium sulfate. But again, this reaction will hinge on whether or not those are barium ions, or if the barium is still in a compound. If it's still in a compound, it won't react, but if there are ions present, it will, and it will form a precipitate. So let's add 3 drops to each. I'm actually gonna make it 5 drops. Okay, so this guy got a little cloudy. That solid at the bottom is actually just residual from the insolubility test in water. So it did get a little cloudy, but there's not too much actual solid formation. So I'll write cloudy. Whereas this guy, it's now super dark, and if you swirl it around, you can actually kind of see some solid in there. I don't know if you can see that dark pink spot. Try to find it. Just take my word for it, there's some solids in there. So with the barium chloride, which remember was soluble, we do see solid precipitate form. With the barium sulfate, so the solid at the bottom, ignore that, that's from the solubility test. We're just gonna look at the solution itself, and it's still pretty clear, so no precipitate formed. And that's the same result for the sodium carbonate and the sodium chloride, which we would expect because there's no barium in those compounds. So no result, no result, and no result. So coming on over to the reaction with sodium sulfate, the barium carbonate got a little cloudy, but not too much. Barium chloride, on the other hand, had a precipitate form. Barium sulfate, no reaction. And that was the same for sodium carbonate and sodium chloride. So now our last little test will be on these guys, and it will be adding this silver nitrate, the 0.1 molar silver nitrate. And what this will search for is the presence of a chloride ion. If there is a chloride ion present, it will form a precipitate. Let's just quickly go through and add some drops to each of these. Okay, so barium carbonate, nothing happened. Now barium chloride, whoa. It got very cloudy. If you look on the top, you can actually see some solid formation. So precipitate definitely happened with barium chloride, as expected, because there's a lot of chloride ion in there. It's barium sulfate, no reaction. Sodium carbonate, no reaction. And then lastly, sodium chloride, a big reaction, lots of solid formation. So, coming on over. So barium chloride, no reaction. Barium carbonate, no reaction. Sorry, I keep misspeaking. Barium chloride, solid form. Barium sulfate, no reaction. Sodium carbonate, no reaction. And then lastly, sodium chloride, lots of solid formed. So that is part one. We have all of our observations made. Again, I will post all of this data, so don't be stressed out trying to rewind to make sure you're catching everything that I'm saying. So now we have this mixture. I've already put it all together. There's 2 compounds in here. So first things first, let's check the solubility. So there's a lot of solid in there, so I'm actually going to add a bunch of water just to really make sure. Actually, now that I'm looking at it, I think this test tube is a little dirty. So I am going to remake the mixture with a cleaner test tube. So I'm going to turn the camera away so you don't see what compounds are going in here. Okay, so I've remade the solution and I'm adding water. Now since there's 2 pea-size amounts, that means that there's twice as much compound as there was in the part 1. So I'm going to add twice as much water just to really make sure we're getting the best results. And it looks like both of the compounds are at least dissolving partially. So they're trying to dissolve. Now there might just, I think the solution is pretty saturated. So that's kind of like makes it a little bit difficult, but they are definitely both dissolving at least partially. So since I had to add a bunch of water, I'm going to transfer some to another test tube just to make the test easier for the rest of this part. And now that's definitely easier to see that the solution's pretty clear. So for our unknown, we added water. It was soluble. So that tells me that both of the compounds we're using are soluble compounds, or at least slightly soluble. Now, let's move on to the second part. We're going to add the universal indicator. This will help us determine the pH. So, shaking it up as it goes through, we can see it is a dark blue, which is a somewhat unusual result, but it's getting darker the more I mix it. So I'm going to add a little bit more. Well, no, I don't need to add a little more. I'm just going to shake this up a little bit. So this appears to be a dark blue, which seems to be almost in between some of the results that we got, because a dark blue kind of corresponds to about probably closer to a 9. Yeah, so I would say this is about a 9. So it's pretty basic, but not quite as basic as the most basic compound. So maybe there's 2 different compounds of 2 different pHs that are bringing it down. So I would call it basic pH around 9, or was it 9.5? Yeah, around 9. So that is the pH. For the next test, we're going to add the nitric acid until it turns red. And we're looking for the presence of the carbonate ion. And look at that. So it is fizzing a little, but it's kind of hard to see on the video because there's small bubbles, but there is some fizzing present. So it turned red with fizzing. And now lastly, I'm going to divide the solution up, and we will check for the presence of chloride or barium ions. Okay, so first things first, I'm going to react it with sodium sulfate. This will check for some barium. And look at that, that's a definite positive result. There's some clear solid forming on the top. So when sodium sulfate was added, some solid formed. And then lastly, the reaction with silver nitrate. This will test for the presence of chloride. Oh yeah, definite solid formation. You can even see it on the sides. So that's a positive result there. So when silver nitrate was added, solid formed. So to sum up our unknown, it was soluble in water. When the universal indicator was added, it was basic with a pH of around 9. When we added the nitric acid, it turned red with some fizzing. Then when we added sodium sulfate, there was a solid formation. And when we added silver nitrate, there was a solid formation. So with that, you should be able to deduce what those two unknowns are. So I will, remember, I will post all of this data with this video, and I hope you're having a safe time. I hope you're practicing social distancing and all that. Hopefully I'll maybe see you at the end of the semester. Bye.